our video about the process application in the cost of goods software package provided by Rondex Pharma. So the process portion is underneath this button with the gears. This is a really key part of the application. So want to be a little careful and speak about this one quite carefully. So there's in this project there's a number of different processes that are used. Some of these are different variants of the same step because we're making an analysis of three different potential processes. So let's start by looking at this process. So this is a cyanide addition. So what this is really is a database of the bill of materials for this step. So what you see is we name the step. In this case, we give it a direct name. We state the material out. We state the molecular efficiency of the step. And then we can put in some comments. In this particular case, we make the comment that this step is based on an example from the world patent 9640-617. We replace the hexane with heptane. We suppose that that the heptane is 95% recycled. This is an image of the step. This is simply pasted in from a ChemDraw image. So you can see what we're doing is we're taking this 617 liquid and we're reacting with potassium cyanide to give us the corresponding cyanide compound. So going back to this, you'll see that the limiting reagent in this case is potassium cyanide. In this case, you see that the limiting reagent is potassium cyanide. The substrate is 617, and we have a feature that allows you to see the equivalence of a reagent in a step. So you see in this case, it was 14% excess of the substrate. But to show you some of the other features for a process, I'm going to say that this particular process is engaged in a calculation downstream, so I can't alter this process step. So to show you some of the other features, I'm going to do a save as. Okay, so I had copied the title, and now I'm just going to make a new title. I have to make a new title or it won't let me do it. So now we're saving as. We're creating a new process that isn't linked to anything else in the project right now. And now you see all these great fields now become open. So you can see I can choose a different material output, which obviously I won't do. I can change the yield. I can change all of these material quantities. Now, one thing I'm going to do here is I'm going to change the GXS to a different number, to 10% instead of 14% excess. So now I've changed the number of kilos input of the substrate to conform to a new number of equivalents. This feature is extremely handy when you don't yet know the exact batch ups. You have a rough idea how much is going to have to go in for the key materials, and you know roughly what their stoichiometry is going to be, but you haven't taken the time to figure out how many kilos it is. Well, you don't have to. You can simply enter the excesses as you're going and make a bill of material from there. As you recall, this is a liquid. This was probably entered originally as number of liters, and then we converted it to the number of kilos. So in this particular case, the 665 makes 732 kilograms. So I can change that. And now, see this 20% excess. Maybe we don't want that. We want it to be 1.1. So you can go back and forth with these things. I can drive it back to what I originally desired. To add a new compound to the list, I go to this button, and then you can draw from anything in the inventory that hasn't already been entered. You can't enter something twice. The program won't let you make that mistake. So let's say we wanted to add some potassium fluoride, and we wanted there to only be 10%, 10 molar percent relative to the potassium cyanide. So then that would be 15.4 kilograms. So this shows some of the features of the process step. And this now we have described the efficiency and all the key economic factors that comes from a chemist's laboratory notebook for a particular process step. So thank you very much for your attention.